Hello, Mr. Berry's geometry class. I'm looking at what is due on the 9th of March. It's 22 through 29 on this page here that's on my screen. Printer's not working today, so yet today, so I'm just going to show you off the screen what to do. I'm going to talk about the odds to begin with, and then I'm going to give you help with the evens too. So number 23, taking a look at this triangle here, if I need to figure out what this x degree is for this angle, notice that I have the information of the opposite and the adjacent. So opposite, adjacent, OA goes with that acronym TOA, TOA. Remember, we've memorized the phrase so, ka, toa, and since I know opposite and adjacent, I'm going to have to use the tangent for that x that's in number 22, or 23. So if I take the tangent of x, that's going to equal 8 over 5. So I use that tangent -1 inverse. It's the tangent inverse function. So you have to hit the second. So you hit second, and you hit, I hit it twice. So it should pop up like that, and then I put my 8 over 5, 8 divided by 5 in parentheses, and I hit it, and it gives you the answer right there. So it's 57.9, or it would be 58. Just figuring out what perspective you're looking at to figure out which formula to use, which function, sine, cosine, or tangent to use. You just got to look at the perspective and what you're given. So for instance, number 25, I'm given to this x value, this is the adjacent and the hypotenuse. So adjacent and hypotenuse is AH. Which one of these has AH in it? It's this one, so I'm going to have to go with cosine. So I use the cosine -1 function, and I do the adjacent over the hypotenuse, and I get 59 degrees. For 27, from this perspective, I'm looking for this value, this angle here. I am given the opposite and the adjacent, so OA again. So that would be OA. Which one has OA in it? This one, tangent. So I'm going to use the tangent function, inverse function, to figure out what the angle is, and that would be the opposite over the adjacent, the 0.34 over the 0.15, and that gives me 66 degrees rounded to the nearest degree. Now, for help on 22, 24, and 26, for those, you're going to be using the sine, cosine, and sine again, and those numbers 5 over 14, 9 over 13, and 17 over 41. That's a 41 there. It's kind of sloppy. All right, looking at number 28. Hopefully you're pausing this and getting this down. 28, they're talking about a rhombus and the diagonal length of 5 and 3. So I just drew it. And so, I couldn't really do much with 2, I'm sorry, not 3, 2. 5 and 2, the diagonal lengths. So the longer one's 5, the shorter one's 2, right? I couldn't really do much with the 5 and the 2. So I know that they are bisected and the angles are bisected. So if I could half these, so this 5 is actually 2.5 and 2.5, and this 2 is actually a 1 and a 1, I could figure out what this angle is and then just double it, because the angles are bisected also in a rhombus. So I need to know this angle. I have the opposite and the adjacent. Opposite adjacent is tangent. Opposite adjacent, the O and the A, is tangent. So if I take the tangent inverse of that, and it's 1, the opposite is 1, the adjacent is 2.5, I get 22 degrees. So this little angle here is 22 degrees. That means this is 22 because it's bisected in a rhombus. So 22 plus 22 is my 44 degrees. I just multiplied that by 2. Okay, now for this one, the bigger angle, I'm going to call that one Y. Okay, so if I want to know this angle, here's my opposite, and now here's my adjacent. Remember, it depends on the perspective. So I have a different perspective, so it's flipped. I have a 2.5 over a 1 when I'm working the tangent. And so I plug in that, that second function, tangent -1, on my calculator, and now my opposite is 2.5 over 1, so I have 68. 68 times 2 gives me 136. I'm just rounding to the nearest nearest degree. Notice when you add these two up, you get 180. So remember, they are supplementary angles. This whole angle and this whole angle, they would be supplementary in any parallelogram, including a rhombus. So hey, it all works. So there's a little help for 28 also. Working on 29, we're looking at this diagram here. And we basically want to figure out what this length is of the roof, okay? So we have a 25-degree angle, and we have 15 plus 1, because you have to add that overhang there, so it's 16. So we know 16, and we know the 25. We want to know that. So they have a few questions. What is that x? What do you call that? X is basically what the first question is. What's the position of the side of the length x in relation to the given angle? It's the hypotenuse. The second question, what information do we need to find the side length of a right triangle? The side length, let me read that again. What information do you need to find a side length of a right triangle? You need to know an angle, which we got, and we need to know another one of the sides. So, and we got that 16. So I listed them literally there. And then which trigonomic ratio would you use? And cosine adjacent over hypotenuse. I used it. I took the cosine. 25 degrees equals the adjacent 16 over x. I don't know what x is. I multiply both sides by x, okay, first. I'm starting to isolate it. And then 16 divided by the cosine of 25 gives me, it's about 17 feet 8 inches. Came out to be like 17.6 something of a foot is 8 inches. Roughly, so it's about 17 feet 8 inches is going to be the length of that side, which is going to be the roof. Okay, hopefully this helps, and good luck with the rest.